Okay, we're continuing our run through Sudokuvania, Digits of Despair. Hopefully this is the second to last video of this series. We'll see. Anyways, let's continue. We were on the Filamino portal. We need to divide the 6 by 5 grid into regions or polyominoes and enter into each cell a digit equal to the size of its region. Regions of the same size cannot share a cell edge. Hold up. Okay, divide the 6 by 5 grid into regions or polyominoes and enter into each cell a digit equal to the size of its region. Regions of the same size cannot share a cell edge. Okay. Note that the last column is also part of a Sudoku grid, and digits may not repeat in it. Okay. So, we got to the wrong spot. Okay, we need to be able to see this Filamino. Okay. We have something of size 9. We have something of size 6, 2, 3, and 1. This 2 is different. This 1 is different. So this is a Filamino of 1. Okay. This has to be 2. So this is 2. And therefore this is a Filamino. This has to be 6. This is 9. This is 1, so that's done. So this has to be 3. This is 9. This is 6. This has to be 6. Therefore, that extends this way. So this also has to extend to 9. But the 9 has to go somewhere. So this is not part of a region. This 6 must extend to here. So the 6 is not part of 9 here. Or sorry, this 2. This 9 has to go somewhere, so this 9 goes down. Therefore, this 3 has to end here. This is a 1. So this is a 3 here. We have to have 9. So we have 1, 2, 3, 4. Okay, so we need, okay. This is 30 in size. We have 2 2s, we have 2 1s already. So that adds up to 6. We have a 3 that adds up to 9. And then we have 15. So 15 plus 9 is 24. We have to have 9 here. Well, we don't have to have 9. This is definitely 3. 24. We need 5 digits here. We only have 6 left. 6 total digits we can fill left. And so it's filled. We need 3 separate digits aside from 6 and 9. So we probably need 6 all the way here. Therefore, this is going to be 6. One of these is 9. We probably need a 2, a 3, and a 1. So this is going to be 6, right? This is to get, like, if otherwise, okay, say we had anything other than the 6 and the 9. Well, okay, say we had either the 9 or the 6b here, but not both. The problem is right now we have 6 and 9, that adds up to 15. We have 1 twice, so that's 17. 2 twice. That's 21, and 3, that's 24. So we have 6 cells to add up to the 3 unique digits. But the 2 here can't be a repeat, so we need 3 completely new digits. Sorry, 4 completely new digits, assuming 6 or 9 is there. But if that's the case, you can't have 4 unique digits ever add up to 6 or less. 10 is the minimum. So you have to have 9 in one of these two spots. We need a 2 also, and we need 1 and 3. Well, this then has to be 3, because we need these digits all to be in this area. So 9 is one of these, 2 is going to be one of these, and 3 is going to be one of these. So we have 1, 2, 3, and 9 here. But if this can't be 9, because 9 does not connect to it. If it's 2 or 1, the problem is it doesn't fill out enough. So this has to be a 3 here, which makes this 3 and this 3. These cannot be 3, so it's 1, 2, and 9. If this were 2, the problem is that would connect that way, and that would be a 2. So this can't be 2 here. This is either 1 or 9. So this Filamino is... oops. Edge only. It's there. So that's 3. We need a 2, a 1, and a 9. If this is 9, the problem is the only way this can be 9 is it connects that way, right? And then the 2 would have to be both of these. This would be 2, and that would break. Actually, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's too big. So it cannot be 1, 2, 3, 4, 5, 6, 7, 8. That doesn't work because the 2 is not a 2 area here then. So this cannot be 2. This is 1. These cannot be 1 here. This 2 has to be a 2 either that way or that way. Either way, this has to be a 9 then, because this 2 over here cannot reach. The 2 is going to be 2 that way, and then the 9 is going to be the other 9. So this is a 2, 9 possibility. But this 2 has to go either here or it has to go this way. We don't know which way it is. Either way, there's going to be a 2 in one of those two spots. So this cannot be 2 because you can't share an edge with the region of the same size. So this is 9, which makes that a 9. This is 2 and 2. And we'll fill out this Filamino. It fills out that way. This 9 has to then go this way, which means this is 2. So this is 2, this is 9, this is 9. And we got the Filamino portal through to... what is this? We are in grid 7, designated by elsewhere. It is disorienting seeing the regions of this or otherworldly prairie stretch out into the distance. Actually, did I even read the Filamino? Grid X, designated by portal. The world seems stretched in this interdimensional tunnel where Sudoku rules do not apply. Okay, so we were doing Filamino. Now we're entering in Grid 7, designated by elsewhere. It is disorienting seeing the regions of this otherworldly prairie stretch out into the distance. The ground doesn't feel quite solid. Irregular Sudoku. Enter digits from 1 to 9 into each row, column, and marked region. Oh, okay. Right. I added these lines, so let's remove those lines then. Yeah, let's remove all the lines. Because that's very confusing. Okay. Oops, I think this is a line too. Oops. No, this is a region by itself. So, oops. So this is a region. Okay, so enter the digits from 1 to 9 into each row, column, and marked region. Okay, and that's all we have. We have a German whisper line here. That means this is a region. This is a region. So 1, 2, 3. Okay, so let's this 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a region. This is a region. 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a region. So then these are the regions here. Right? Because this cannot be, oops. This cannot be, there's no region demarcations there. Therefore, this almost certainly has to be a region by itself. And this is likely a region. This is almost certainly a region here. Okay, we are elsewhere. These are 4, 5, 7, 8 for these 4 cells. These 2 digits here. So these are also 4, 5, 7, 8. Oops, this is not going to go the other way. I don't see a digit here, so this sky peeper doesn't actually have a digit anywhere. This doesn't have, this has 3, so 8 could be there. So 1 cannot be any of these cells, so 1 does have to be here or here. This was 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Do we have any other quests? Wall sandwiches. Find Mr. Snake's hidden food. 17? When did we get snakes? Ugh. I'm just looking for rules. Maybe we might have different. So this is saying it adds up to 17, 17, and 17 between 2 unique digits. Does that give us anything? I don't even know. This was dark cells. Okay, we did that. That's all done. Okay. This is a German whisper line. So we have 1 low, 1 high here. This is low or high, which is next to the next one. Does that really give us any information? So one of these is 4, 5, 7, or 8 because it has to be matched that one. One of these is 4, 5, 7, or 8 because it must match this one. So these two match these 2 cells. Six cannot be here for this region. So 6 has to be one of these 4. 9 cannot be here, and 9 then has to be one of these 4 cells. 1 is one of these regions, these cells. So 1 has to be one of these, and then 1 has to be one of these. So 1 can never be here. This then is 2, 3, 4. Okay, so this cannot be 4 or 6, because if it's 4 or 6, it sees 2 unique digits on the germ whisper line. This can't be 4 or 6. So this is 2, 3, 7, 8, 9. This is also 2, 3, 7, 8, or 9. But these could be 1, 2, 3, 4, 6, 7, 8, 9. So we just have irregular Sudoku. I don't know what this is. That's interesting. This sees 3 digits, so this can be 7 at most, but it could be any of the 7. What is the the exclamation point was falling. Do we have any other information for any of the regions? Probably not. We're probably supposed to solve this irregular one. Let's take a look at this. Okay, this has to be 8. Wait, no, this is a German whisper line. Never mind. 3. This has to be a 2-8 pair here to match the rest of the column. This has to be greater than 3. So it could be 4. Okay, this is 1, 2. This has to be a 1, 2 pair here to be next to a 7 on a German whisper line. This would then be 6. It cannot be 7. Cannot be 5. It's 6, 8, or 9 here. This is greater than 1 or 2. This can't be 2 because of the 2-8 pair in the box. So this is 1. This is 2. This must be 2 next to 8 or 9 here. This is 4, 5, 6, 7, or 9. This has to be 3, 4, no 5, 6, no 7, 8, or 9. Okay, so that doesn't help us much. This is 4, this is 6. So yeah, we're not going to be able to get too much solving there. 8 cannot be any of these. So the rest of this box is 4, 5, 6, 7, 9. So 9 cannot be here, cannot be here. But it could be the last one here. 2 is here. The rest of this is 1, 3, 4, 6, 8, 9. But obviously 1 cannot be here. And 2 has to be one of these 3 digits here. We know 6 is one of these digits. 9 has to be one of these 4. So it will not see any of these digits no matter what, because 9 has to be one of these 4. To get 3 in the skyscraper, we need this cannot be 9 and that can't be 9. Okay, that doesn't seem to help any. So we probably do have to do the regular Sudoku. Okay. I don't know how to zoom in correctly. Zoom. Zoom, okay. So we do have to solve this. We have, okay, so 6 cannot be here because 1 can't be here. Therefore, 6 has to be one of these 3 digits here. This cannot be 6, so 6 for the rest of row 3 has to be either, okay, so 6 cannot be here then. 6 cannot be here because it can't be next to a 2, 3, 7, 8, 9 on a German whispered line. It can only be next to 1. So this can't be 6. This can't be 6. This can't be 6. Aha. So 6 cannot be here in this region. It can't be here because it can't be next to it has to be next to a 1 on a German whisper line. Can't be here because this can't be 6, and this has to be the 6 in this region. So this can't be 6, this can't be 6, this can't be 6. Where is the 6 in this region? It must be here. So this is 6, which means 6 cannot be here. This has to be the same as with that digit then, because this can't be 6. Therefore, this is a 6 here. We have, it has to be 4, 5, 7, 8, or 9. Well, it can't be 4 or 5 here, because it's next to 2 unique digits, and 5 can never be on a German whisper line. So this has to be 7 or 8. Therefore, this is 7 or 8. That's actually kind of clever. Anyways, this can't be 6 here. This can't be 6 here. Therefore, where is a 6 in this region? It has to be here. And it must be a 6 with a 3. So this is a 3-6 pair. This is 7 or 8, which must be next to specifically 1 and 2. Because 3 is no longer possible in either of these regions because of that 3. This 1 or 2 must be next to 7, 8, or 9. We have a 1, 2, 1, 2 pair here, which leaves this as 4, 5, 7, 8, 9. So 9 does have to be one of these 3 cells here. This cannot be 6. This cannot be 6. Okay, what about 9? 9 could be here. So we don't know what that cell is. It's either here or here. We're not sure which. The only reason why we knew that cell wasn't that is because that had to be a 6 and therefore could not be there. This cannot be a 6 here. We have a 3-6 pair here. If this is low, it's 1 and 4, which would require this to be 9. Otherwise, it's 2 highs here. So this is either 1, 4, or it's 7, 8, 9. Because those both have to be either high or, yeah. That means the rest of this column must contain 1 and 2. So this can never be 1 and 2. We have a 3 and a 6. 6 is here. 6 can't be here. 3 has to be here. 3 cannot be any of these. So we have 3 in one of these cells. We also have 4, 5, 7, 8, or 9 in the rest of this. This can't be 1. So 1 is one of these 3. The rest of this is 1, 2, 4, 5, 7, 8. But this can't be 1. The boss is in one of these areas. We're not sure which. So this matches this. So this cell matches this cell. Therefore, it cannot be here or here in this region or here, so it must be one of these 3 cells. We don't know which. This cell cannot be in these, so it can't be here, so it's one of these 6 cells. Okay. If this is a high, it can only be 9. This can never be 2 then, because this has to match either this cell or that cell, and this is 1 or 2 here. So it's either 3 here, which would force this to be 8 and 9, or this is 9 with this being 1 and 4. So this is 3 or 9. This cell then cannot be the same as that cell. Right? We tried to have 7. If we try to have 7 or 8 here, the problem is the lows here have to be 1 and 4 because we have a 3-6 pair and a 2 in that row. So it can never be the same as this cell. Therefore, this is a 3 or 9 here. It matches this. This is 4, 5, 7, or 8, so this matches that one. So we're marking these. This must match here. What is the remaining digits here? Okay, so for this, for row 8, where is the red cell? It has to be one of these 4. Therefore, it cannot be here, it cannot be here, it cannot be here. This has to be the red, which means this is also 4, 5, 7, 8. Therefore, this can't be the red here. So we know one of those 3 is a red, this is a red, this is a red. In this region, in row 5, it has to be one of these. That doesn't tell us very much. If this is 1, 4, this becomes 5, 7, 8. And this would have to be 9. Right? Because this matches this region. These two cannot be 9. This cannot be 9 because 9 has to be one of these 3. Where is the 9? The 9 has to be one of these 2. Therefore, this has to be a 8 and 9 here. Which means this cannot be 8 or 9 because of the 8-9 pair in the row. This then has to be a 1. This then must be a 3 to be next to both of these, and this must be a 3. We find the boss. So this can no longer be 1. 2 is one of these 2 digits. This 3 matches, cannot be 3 here. Let's do the boss. Okay, so the boss is MTRHHM8G95. Okay. We have Enlightningment, not Enlightenment. You squint into the distance, trying to make sense of this irregular place. You feel so exposed without a box around you. You must be searching for something. You whirl to find someone behind you. She continues speaking. Okay, that's probably. You must be searching for something. She continues speaking over your exclamation of surprise. I could see Sudokuvania through the portal by which you came here. Do you know what is happening in that castle? You explain that you are only looking for knowledge, but she seems to know this already. There is a group of people who have been waiting for Sudokuvania to return. They intend to destroy Sudoku itself with some kind of doomsday device. Even now, they are trying to access the throne room at the center of the castle. I cannot help you, but I can allow you to grow to help yourself. Sit, meditate on the nature of regions. When you can construct a grid with the power of your mind, you will be able to return from this place. So here are the rules. Sudoku, place the digits 1 through 9 in each cell without repeating in a row, column, or box, or region. Sorry, not box. These are regular regions, and it's chaos construction. We have chaos construction. The regions are 9 groups of 9 orthogonally connected cells which do not overlap and whose position must be deduced. Right. There are 3 types of clues in the grid: zipper lines, German whisper lines, and ratio crop key. See below for the rules. For 2 of these clue types, each clue resides entirely in the same region. That is, it never crosses a region border. For the third type, adjacent cells on the clue are in different regions, that they always cross a region border. Interesting. A line following this rule can have multiple cells in the same region as long as each cell on the line is in a different region from its neighbors. Interesting. So we have ratio crop key, where black dots separate digits where one digit is double the other. Not all dots are given. Okay, so chaos construction rules, quick dirty one is it has to be 9 cells which have to share an edge with the shares an edge that connects it to. It must find a way to be able to draw a line from that cell to any other cell in that region just through edges, right? So you could have something region like that and stuff like that. We know 2 of the clue types must have all the cells related to that clue residing in the same region, and the third one must have different regions for those regions, right? Okay. So, the question is which ones are which, right? Okay, so we have ratio dots. These are black crop key dots. They have to be 1:2 ratio. So if this were 2, this would have to be 1 or 4. German whisper lines, adjacent digits along a green line must differ by at least 5. So if this were 3, this would have to be 8 or 9. And then zipper lines, where digits in equal distance from the center of the red zipper line must sum to the digit in the center of the line. Okay. These digits must be 1, 2, 3, 4, 6, and 8. These digits have to be 5 away from each other. So one of them is high. So one of them has to be 6 or 8. The other one must be low. You can never have 4 here. So this is either 6 or 8 here. This cannot, well, these could be 2 unique digits. Or sorry, this could be the same unique digit. Five cannot be any of these. 5 in row 2 has to be one of those 2 cells. These 2 digits must be the same set. If they were both high, the problem is you would have a high plus a high. That's 6 plus 7, or 6 plus 6 at minimum, which is 12, which means that would have to be a 12, which is not allowed to be. Therefore, these are both low. So this is 1 through 4. This is 1 through 4. This has to be 6, 7, 8, 9, and this is 6, 7, 8, 9. Okay, so if the German whisper line is all the same region, how does that work? If this were the same region, so say this was the same region, the problem is, Okay, so it could be if this is the same region here. So that's the only way this is the same region. So if the German whisper line is the same region, because, okay, say this was a different region. Well, the problem is it's only 5 in size, and that can't work. So if the German whisper line is the same region, the zipper line would have to be the same region. If it's not the same region, then obviously the zipper line would be the same region anyways. So we do know that this has to be the same region no matter what. The zipper line is always going to be in the same region. This will make it yellow, I guess. Okay. So this always has to be the same region because either the German whisper line is not the same region or it is the same region, which would force this specifically to be that region. This must be, well, it could be 5 to 9. We don't know which, though. It's probably the Kropki dot is a different region. If the Kropki dot were the same region, then this would have to be the same region. This would have to be the same region. So that's 1, 2, 3, 4, 5, 6, 7. This then would have to be a different region. So if the Kropki dot were the same region, the German whisper line's a different region. So then this would have to be a different region here. So we have 1, 2, 3, 4, 5, 6, 7. This could be 8 and 9 here. That would force this to be red, which would force that to be red. Okay, actually, what if the Kropki dot were different regions? This would have to be a separate region than these two, at least. Well, the problem is, if this red has to be a separate region, it would be small, and it would be 4 at most, because it could not be the same as yellow, because this is already 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, it could be then. This would then have to be yellow, because it would be 4 in size otherwise, but this region would be 1, and that doesn't work. Therefore, okay, so the German whisper line designates the differences between regions. So we know that this is a separate region from this. We don't know actually this one. We know these two must be different regions, and these two must be different regions. So this is a separate region, actually. This has to be the same region. Because again, if we try to make the Kropki dots the same or different regions, the problem is this region cannot connect to these two because they're different regions. Therefore, if we try to go out, it's only 4 if it's not yellow. If it is yellow, this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. But this cell gets blocked and doesn't have its own region. So, therefore, the Kropki dots must be the same region. And the German whisper line divides different regions. So this is a different region, 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 this is a different region. These two must be the same region. This cannot be the same region as blue. It must go out this way, and it's likely part of this orange. These are all part of the same region. We have 1, 2, 3, 4, 5, 6, 7. This must be part of the same region, so it's red. This must be a different region, so then it does have to go this way. So we know then this has to be yellow, because otherwise, this is a separate region than the red, what else can it be? What other region can it be part of? It has to be part of yellow. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the entire yellow region. This red has to go out here. So this is red. 1, 2, 3, 4, 5, 6. And then it has to go out here. That's 7. Let's draw the border around the entire region. Therefore, this is 2 or 4 here. And this has to be 1, 2, 4, 8. This is 1, 2, 4, 8. Because it's all in the same region. This is all the same region. This is all the same region. So this must be part of this region. We're going to make this the red one, and this is going to... Oops. Let's make this green. And this red. This might actually be yellow, but... This region has to be all the same, because this is the same region, and this can only be part of pink now. This is part of the same region, but it can, if this is not orange, it would go here. It has to go here. So this has to be part of this orange region here. This then cannot be part of this region. Okay, so we're going to make this now yellow. And this we're going to make blue. This must be part of a separate region, so we're going to make that dark. It cannot just go, it has to go out here. These are part of the same region, but we could have that being there. This is 1, 2, 3, 4, 5, 6, 7. Okay, let's try to figure this out. This is... These two add up to this one. If this were 5 and this was 1, 2, 3, 4, the problem is this would have to be a 6, 8 pair, and then this would be 3 and 4 added together. So that can't work. So this can never be 5. This potentially could be 6? No. If it's 6, you have 1, 2, 4, and 5 in these cells, right? The problem is 1 or 2 would have to be in a 1 to 2 ratio with 2 or 4. And then you have 4, could be with 8, but the problem is 1, 2, 4, and 8 are already given. So this cannot be 6 either. This is 7, 8, or 9. This is 1, 2, 3, 4, 6, and 8. This is 1, 2, 3, 4, 6, and 8. This digit sees all of these digits here. So it can only be, this digit can only be one of these 3 spots. This is 1, 2, 3, 4, 6, 8. This is also 1, 2, 3, 4, 6, 8. These 2 digits must add up to that. So this is at least 5 because it sees 4 unique digits in the same region. This cell must be one of these 3. We're not sure which. These are also 1, 2, 3, 4, 6, 8. can this ever be 9? No, because these two digits can add up to at most 7. So this cannot be 9. This is then 1 through 6 here. 1 through 6 here. This is 1, 2, 3, 6, 7, 8, 9 as possibilities. If this is 5, these 4 digits would have to be 1, 2, 3, 4, and that would eliminate 1, 2, 3, 4 for these two cells. So this would be a 6, 8 pair, but that's not in a 1 to 2 ratio. Therefore, this can't be 5. If this is 6, this is 1, 2, 4, 5 in that region, and this could not be 1, 2, or 4, or 6. That would eliminate all possibilities for this Kropke pair. So this cannot be 6. So this is 7, 8, or 9. This is a different region than the dark. Because no, it doesn't have to be. It could be the same region. Never mind. These two are the same region. This is a separate region than this. These are a separate region, so this is orange or dark. We're not sure which. This could be dark. Could be green all the way here. Green could go here. The rest of the green region cannot contain 2 or 4 because we have 3 digits that are in a 1 to 2 ratio. Sorry, we have 1 digit that is in a 1 to 2 ratio with 2 other digits. Therefore, it must be either 1, 2, 4 or 2, 4, 8. So this must be 1, 3, 5, 6, 7, 8, 9 here. These are blue or yellow. We're not sure which. This must expand in one way here or here. We're not sure which. Could be both. If this is 6 or 8, this has to be 1, 2, or 3. If this is 1, 2, or 3, it could be any of 6 through 9, though. This could be 3 through 9. This is 1 through 8 here. This digit sees 2 digits in the same region, so this can never be 6. Actually, it can't be 7 either. If this is 7, this forces this to be 1, 2, 1, 2, which only adds up to 3. If it's 8, it could be 2, 3, 2, 3, and that's 1, 4. If it's 9... So if this is 3, 4, this is 7, this has to be 9. Hmm. So 3, 4, 3, 4, and 7 makes this 1, 6, or 2, 5 here. And this would be 9, obviously. If we have 5, it cannot be 1 and it could be 1 and 4. You could have 1, 4, 1, 4, and that's 9. You could have 2, 3, 2, 3, 8, and this is 1, 4. Hmm. So that seems okay. Hmm. Um. Okay, this region could be the same as this region. I guess it could exit out that way. Hmm. I was thinking that it had to go that way, but that's not true. Hmm. Okay, if this dark region is not the same as this one, that means it has to go that way. I mean, it could do something like this. This is fine. These are different regions here. If this is 6, these would both be 1s, and they would have to be different regions. This would then be 1, 2. This would be 3. Is that even possible? So, So say this was 6 and 3. That would eliminate all possibilities for this to have adding up to 7 because you eliminate 1, 6 and 3, 4 there. Sorry, 3. Yeah, 1, 6 and 3, 4 are eliminated. For 8, that eliminates 2, 6 and 3, 5. For 9, it could work. You could have 1, 8, 2, 7. So that's if this is 6 and 3. If it's 1 and 2, you can't have 7 again. You can't have 8. So if this is a 1, 2 pair, that eliminates 1, 6, 2, 5 for the 7 sum. For the 8 sum, it eliminates 1, 7, 2, 6. For the 9, it could be 3, 6, 4, and 5. That does work. For 2 and 4, that eliminates 7 because you can't have 1, 6, and 2, 5. Sorry, you can't have 2, 5 or 3, 4 adding up. It does not eliminate 8. So you could have once, if you have 2, 4, you have possible if you have 2, 4, you have possibility of 1, 7 and 3, 5. And then 9 is fine because 1, 8, 3 and 6 works. If you have 4 and 8, that's the one that allows the most, right? If you have 8 and 4, 7 could be 1, 6, and 2, 5, and that works. 8 could not be there. But 9 could be then 2, 7, and 3, 6. Hmm. And if you have 3 and 6, that eliminates 7 because no 1, 6, or 3, 4, which leaves 2, 5 twice. That eliminates 8 because no 1, no 2, 6, or 3, 5. That leaves 1, 7 twice, and you have 9. So the only thing is if this is 8, 4 is the question, right? Then that would be 7. If this is 6, this would have to be 2, 4, 2, 4, and this is 9. 9 cannot be actually any of these cells because it can't be next to a black crocky. So 9 in the red region has to be one of these 3. Which doesn't really tell us much. Hmm. Okay. Hmm. I don't know. I'm not seeing any really big restrictive things. Hmm. The most promising ones are the red region and the orange region. I don't think we have enough information about the pink region, and the yellow region could be pretty broad also. Hmm. Oh, that's interesting. So if this is 8, this has to be 9, which forces this to be 7. That's interesting. So if this is 8, that means this is 9, this is 7. These have to be 4 digits from 1 through 6, adding up to 7. So it's 1, 6, 2, 5, or 3, 4. The problem is you would have 1, 2, or 3 here. So this being 8, okay, so if this were 8, this was 4, this would then be 9, this would be 7. The 8 would be 1, 2, or 3. But if it's 1 and 2, that would be next to a 1 or 2 here. 1, 2, or 4, but the 4 can't be here. So if it's 1 or 2 here, this is 1 or 2, and this would not work for this zipper line, right? Because you eliminate 1, 6, and 2, 5 there. If this is 3 and 6, the problem is then you can't have 1 and 6 or 3 and 4 adding up to the 7. So this can never be 8 then. Right, this can never be 8. So if it's a high here, this has to be a low as a 1. Interesting. So this is specifically 1, 6, or 8. If this is 6 and this is 1, this would be 2. So 1, if this is 6, this is 1 and 2. If this is 6, this is 3. So this is 1, 2, 3, or 6. This can never be then 8 here. If this is 6, this is 3. If this is 8, this is 4. That's interesting. If this is 1, this is 2. If this is 2, this is 1 or 4. Ah, but if this is 2, this has to be 8. So this can never be 4 here. This can never be 4. So this is either 3, 6, or it's 2 and 1 here. So we know, okay, so it could be 1, 2, 8, 4 here. That's possible. These cannot, well, this could be 9. So 9 in column 8 has to be one of these 3 cells. Because this can never be 9. Hmm. If this is 1, 2, this becomes 6, this is 3. 1 cannot be here. Right, so let's see what happens there. If this is 1, this is 2. This has to be 6. This is 3. Oh, what are the rest of these? So if this is 1, this is 2. This becomes 6. This is 3. This has to be 9, which makes this 8. This can't be 1 or 4 here. This can't be 1. This can't be 3, and this can't be 4. So this has to be 2, 3, and 5. Which makes that 4, that 1. That seems okay. This is 3, 4, 5. Ah, but this fails. 3, 4, 5, 6. That eliminates 3, 4, 5, 3, 4, 5. This becomes 6 and 6. And that fails. Therefore, it cannot be 1 there. So this has to be a high, which means this is 6 or 8. This is 1, 2, or 3, which could be with 1, 2, 3, or 6. 6 or 8 is with 3 or 4 here. So if this is, actually that's interesting. If this is 6, this is 1, and this is 1. Therefore this is 2, this is 3. This 6 and 3 eliminates 1, 6, and 2, 3, 4, adding up to 7, so this can't be 7. It also eliminates... what else does it eliminate? It eliminates 2, 6, and 3, 5, adding up to 8. So this must be a 9 then. So this would be a 9, this would be 8. This then would have to be 1, 8, 2, 7, or 4, 5. Okay, so one thing we know then, 9 can never be here, obviously. So again, if we try to make this 6, 1, 1, this is 2, this is a 3. This has to be 9, which forces this to be 8. Therefore, this cannot be 1, it cannot be 4 here. This must be 2 and 3 adding up. Therefore, this is 3, this is 2, this must be 5. This can't be 1, so this would be 4 and 1, but we fail because neither of these can be 1 now. So, we know for certain this cannot be 6. This has to be 8, which makes this a 4. So this is 8, this is 4. Okay. So this can no longer be 8. So if it's 7, it has to specifically be 1, 6, and 2, 5, adding up to 7. If it's 9, it's 2, 7, and 3, 6, adding up to 9. So 8 is here. This is 4. Either way, that means the 2 and the 6 have to be here, right? If it's 7, it's 1, 6, 2, 5. If it's 9, it's 2, 7, 3, 6, adding up to 9. And either way, 7 has to be in one of these 5 cells then. So this is 8. Uh, hmm. If this was a 9, so say this was 9, then we would have 2, 7, 3, 6 here. This would then be 8. This would be, could not be 4 here, so it would be 2, 3, 2, 3, which would add up to 5. This could not be 5. It would be 1, 4, and 1, 4 here. That seems plausible. Hmm. Okay. That doesn't tell us very much, unfortunately. Say this was 3, say this was 7. If this was 7, this has to be 3, 4, and 3, 4. So these can't be 3, 4 here. This would then be 9? Is that right? Yes, this would have to be 9 to be next to the 3 and the 4. This would have to be 8 or 9 here. This would then be 7. So we could delete those. It's 1, 6, or 2, 5 here. That seems fine also. Hmm. Okay. This is pretty hard for a chaos construction too. Oh boy. What happens if this is 8 is interesting. Well, maybe not. Hmm. Hmm. That's interesting. So if this is 1, 2, 1, 2, that would require then 3 to be one of these. And 3 would have to be with 9 here. Otherwise, this is obviously... Okay, so this can't be 3 here, because if this is 3, that would be 6. Otherwise, this is 3 and 6 here. So none of these cells can be 3 ever. It could be 1, 2, 5, 6, 7, or 9. Obviously, 5 cannot be here. So if this is a 1, 2, 1, 2 pair, that forces 3 to be here with 9. This would then be 6 or 7, which would force us to be 1 or 2 here. If this is 3, 6, you could have a low here. And this would be 1, 2 with 6, 7, 8, or 9. And you'd have one of the lows here, 1, 2 with 6 or 7. So it could be 3, 9, 1, 2, 6, 7. That's fine. If this digit is the same as that digit. Oh, that's actually interesting. So say this, okay, this digit cannot be any of these 6 cells in the red region. It could be the same as that one. It could be the same as those two. Say this was here. If this was an 8, this could only be with 4, and this would be 8, and that would be 4. So that doesn't work. If it's a 1, same problem. This is 1 and 2. That would be 1 and 2, and that would be problematic. So this would have to be a 2 or 4 if it matches that one specifically. Well, if it matches that one, you would have a 2-4 pair here, which means this could not be 2 or 4. This would be 2 or 4, and it would be with the other 1 or 8. That's possible. Oh, what are the possibilities for this is the question. So if this is 9, it cannot be 3 and 6 here adding up to 9, because then this 3 and 6 would be in a 1 to 2 ratio with the other 3 or 6, and they would clash. So if this is 9, it specifically has to be 1, 8, 1, 8, which forces this to be 2, 4, 2, 4. That's interesting, which would force this to be 1, 8, which would force that actually to be the same as that cell. Wait, but that wouldn't work, because then this 1, 8 would be in that 1, 2. Okay, so this can never be 9. That's what we learned from that. So if we try to have this as 9, the only two digits, it cannot be 3, 6 adding up together. It has to be 2, 1, and 8 adding up together to add up to 9. But this 1, 8, 1, 8 pair is with a 2, 4 pair here. This becomes a 2, 4, 2, 4 pair in row 8, which eliminates 2 and 4. But then again, this 1, 8, where does it have to be? Cannot be here. It would have to be here. And this would be the 2 or 4 with it, but then this would be the same one. So that wouldn't work there. So this can never be 9. What if this is 8? If this is 8, it cannot be obviously 1, 8. It would have to be 2 and 6 added together here, right? The 6 would be with the 3, so that's possible. And the 2 would be with the 1 or 4. That's also possible. Okay. So we know one of these two is a 9. This cannot be a 9 then here. This yellow requires a 9 somewhere. But it could be just as easy as going up there. Well, can't go up here. It could go up here, and then the blue could go around. Or the blue could just go straight through. Either way, one of these is 9. So this cannot be 8 at all here. This is 1 through... Okay, so if this is 8, this is 2 and 6. This would require this to be 3. So if this is 8, this has to be 2 and 6, which would mean this is 3, which would mean this has to be 1 and 7 added up together. So we know one of these 3 digits is 7, right? Because if this is 8, this requires this to be 2, 6, which requires these to be 3 here. This would then be 3 and 4 in a 1 to 2 ratio. This would then be 1, 7 here. Okay. So this can never be 7 here. Otherwise, if this is 7, it could be 1, 6 here. It could be 3, 4. So either way, I think we have... Okay, so if this is 2, 6, one of these has to be 3. If this is 1, 6, one of these has to be 3. If this is 3, 4, obviously one of these is 3. So 3 has to be... So 3 and 6 have to be in one of these two sets. Oh, that's interesting. So if this is 3, 6, obviously neither of these could be 3 or 6. If this is 3 or 6, which one of them has to be, so one of these is a 3 or 6, right? If this is 8, this is 2, 6, 2, 6, and therefore 3 and 4 would be one of these, right? This could never be 3 and 6 if that's the case, right? So again, if this is 8, this is 2, 6, 2, 6, which forces this to be 3, 4, 3, 4, because 6 has to be next to a 3 on with a black crocky dot. Therefore, 3 and 6 can never be here in the rest of this red region. If it's 7, obviously it's 1, 6 here, which would again require 3 to be in the black crocky dot. Or it's 3 and 4, which require the 6 to be in the black crocky dot there. So 1 and... Okay, so the possibilities are, again, if this is 8, this is 2 and 6. And this is 2 and 6, which forces this to be a 1, 7 pair here. Therefore, this is a 3, 4 pair. Therefore, this would be 9, and this would be 5. That's fine. So this would be a 3, 4 pair, 3, 4. Otherwise, if this is 7, this could be 1 and 6. It could not be 1 and 6. So say it was 1 and 6. Okay. So let's try now if this is 7. If it's 1 and 6, the problem is that requires 3 to be here and then 2 to be here. But 1 and 6 adds up to 7, but these two can never add up to 7 because we've eliminated 2, 5, and 3, 4 there. So this can never be 1, 6 if that's the case. It would have to be 3 and 4. Okay. So if this is 7, it would have to be 3, 4, and 3, 4, right? 3 would be in a 1 to 2 ratio with 6. So therefore, this would have to be 2, 5, and this would then have to be 8. So, either this is 3, 6, which eliminates 3 and 6 as a possibility here, so this couldn't be 3, 6, or this is 3, 6, which eliminates 3, 6 as a possibility here. So either way, this cannot be 3 and 6. It's 1, 2, 4, or 8 here. So if this is 2, 5, this is 1, 9, 1, 9, if that's the case. which means, okay, so if this is 7, this is 2, 5, 2, 5, and we have 1, 9, 1, 9 here. Otherwise, this is 8, this is 2, 6, 2, and 6. And this has to be 1, 7, because the 3 has to be here. And this is 3, 4, 3, 4. This would be 9, and this would be 5. So those are the possibilities for the red region. So this is specifically 1 or 9 here. Say this was a 4. If this is 4, this has to be 2, which makes that a 1. This 4 eliminates that as a 4, 8 pair, or as 2, 4, so this is 3 and 6. This can't be 4. 4 can't be any of these. Therefore, this must be 4, and this must be 8. Which makes that 3 and 6. This is 7. This is 2 and 5. This is 9. So that seems kosher. This would be 9 then. So if this is 1, this has to be 8 here, which makes this 4, that 2. This 8 means neither of these can be 8, so this has to be 8. Ah, and that fails. Because this is 2, 6, this has to be 1, 7, but we already have a 1 here. So we know this can never be 1. This is a 9. So this can't be 9 here, this can't be 9, this cannot be 9 here, interestingly enough. So if this is 3, 9, this is 3, and this would have to be 9. So this cannot be 3 here. This cannot be 8 anymore. It could be 1, 2, 4, 2, 4, 8, or 4, 2, 1. So 1, 2, 4, 2, 4, 8, or 4, 2, 1. This can never be 2 then. This is 9. So this cell must be the same as one of these two, because it can't be that one ever anymore. Okay, so this can never be 2. If this were 2, this has to be 4, this would be 8. Well, where is this 2 in the red region? Can't be any of these, it has to be here. So this is 2, but that forces this to be 4. So that doesn't work. So this cannot be 2, this is 1 or 4 here. If this is 1 or 4, this must be a 2 then. Right? So this is 2, this is next to 1 or 4 then. So these are 1 or 4. So that in the green region, you cannot have a 1 or 4 in the rest of the region. This cannot be 2. If this is 1, that makes this a 1, which means this cannot be 1, 7, adding up to 8. So this is 2, 5, this is 7, and this is 3 and 4. If this is a 4, this has to be 4, which makes that a 3, which makes that a 7. So either way, this has to be adding up to 7. So this is 7, which means this cannot be 1 and 7. It's a 2, 5 pair, which eliminates 2 and 5 from the rest of the box, or the region, so this can't be 5. This is a 1. This can't be 2. This has to be 3 and 4 added together, which must be with 6 and 8. So both 3 and 4s see that cell. So this can't be 4. These cannot be 1. So this can't be 6 here. This can't be 2. Because the 6 requires that to be a 1 to add up to 7. This 2 means this can't be 2, so this is 5, which makes that a 2. This can't be 5 either. That's interesting. This can't be 2. Okay, if this were a 3, 9 here, so they say this was a 1, 2 pair. One of these has to be low, and one of them has to be high. The 3 has to be the low, and therefore can only be with 8 or 9, but 8 is eliminated by the 8 in the column. So this can't be 8 or 9. This then has to be 3. This would be 9. The 3 would have to be next to an 8 or 9. Again, this 9 would eliminate that, so this would be an 8. But this 3 eliminates this as a 3, 6 pair. So it would have to be 4, 8 here, and you'd have an 8 here and an 8 here. That's not allowed. So this can never be 3 and 9. This then has to be 1 with 6 or 7. This can't be 1 and 2. This must be a 3, which makes this a 6. So none of these can be 6s. This is 3 and 6. If this is 6 or 7, it has to be with a 1. If it's 1, it could be with 6, 7, or 8 here. Either way, one of these is a 1, so this can never be 1. So this is 4, which makes this a 4. This is an 8. This is 3. This is 6. So none of these can be 6. This 4 means this is not a 4, so this is a 1, which means this can't be 1. This is 6 and 7, which has to be with a 1. So this cannot be a 1 here. This is 7 or 8. These digits are 5, 7, and 8 remaining. Four has to be one of these, so 4 is one of these two cells. These can't be 1 anymore. There has to be a 5 here. This cannot be 4 here. So if this were 5, the problem is this would never add up. Right? You'd have 2, 3. Okay, this can't be 1 or 2. If this is 5, this would have to be 2 and 3, but then these two are in the same region, and this cannot be 1 and 4. So this can never be 5. It's either 6 or 7 here. This can't be 8 anymore because of this 8. So this is 9, which makes this a 7, which means this is a 1, 6, 2, 5 pair. This cannot be 7 here. This can't be 3. This can't be 3. This can't be 6. This can't be 4. So to add up to 6, this would have to be 1 and 5. So if this were 6, this is 2, 4. And this is 1, 5. If this is 7, this has to be 3 and 4, but then that would eliminate all possibilities for that cell. So this can't be 7 then. Actually, this couldn't be 3 and 4. So either way, this is 1 then. This is always 1. This is 5 or 6. So one of these is a 6. If this is 6, this is 2, 4. If this is 7, it's 3, 4. Either way, this is a 4 here. So this is 4, which forces this to be a 9. So this obviously can't be the same region as that. This is a 4. It's with 5 or 6, so 6 cannot be here. This can't be 9. It cannot be 4. It still could be 3 if this is 1, 2, 1, 2, but if this is 1, 2, 1, 2, that forces this to be... Okay, this can't even be 8. This is 1 or 2, so it has to be with 1, 2, or 4. So this can no longer be 3 adding up with 1 and 2. If it's... This can no longer be 8. So either one of these has to be a 2. It's either 2, 1, or it's 2, 4. This cannot be 7 because of this 7. These can't be 1, so we need 1 to be one of these two cells, which means this has to be 1 with 6. So this has to be 1 and 6 here. That forces this to be a 2, 5 pair, which eliminates 2 and 5 in the rest of the row. This can't be 1 or 2, so this is a 3. This requires this to be 6, 7, or 9 now. This can't be 6 because of that 6. This region is different from this region. So now we know this has to go this way. So it has to continue on here. This, we don't know if that's the same region. It probably is, but we don't know. This is a 1. The remaining digits in row 7 are 3, 5, 6, and 8. This can't be 8, though, because of this 8. Remaining digits in row 8 are 3, 6, and 7. Okay. This yellow needs a 9. 1, 2, 3. Can it? Okay. The question is, where is it going to get its 9? It can't be here because this is a different region because of the different region rules for one of the rule sets, which is the German whisper line. Can't be here because same reasoning. If we try to not have a 9 here, and we try to go, actually, yeah, where is this yellow getting a 9? Can't be part of pink, can't be here, can't be here. If we try to, say we try to make it out past here. Well, first of all, this would not be a 9. Assuming this is not a 9, it has to go, actually, I guess it could go something like that. That is possible. This cannot be 2, because one of these is a 2. So it could be 1, 4, 1, 4 adding up to 5. It could be 2 and 4 adding up to 6, or 1 and 5 adding up to 6. It could be 2 and 6 adding up to 8, or 1 and 7 adding up to 8. So any of those works. These cannot be 6 because of the 6 here. This orange needs a 3. I guess it could be here, technically. It's unlikely. This can't be 3 here. So one of these two is a 3 here. We need a 3 and a 9 in this orange area. Okay. So the orange needs a 9. The yellow needs a 9. The orange cannot reach this. The orange cannot reach here. So the yellow could be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's problematic. So if the yellow tried to have a 9 go outside, it would have to go like this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this would cut off the blue. And the blue would not be less greater than 9. So therefore, this yellow cannot get a 9 except for from here. And it cannot go to here, because if it goes to here, this blue is still cut off. Therefore, this must be part of yellow and is a 9, which makes, oops, this is a 9, which makes this a 7, which makes that a 6. This must be 2 then, this must be 5. This can no longer be 5. This can't be 6 because of that 6. This is 7 and must be part of blue. So this is a boundary, definitely. The blue has to be able to go here. So this yellow cannot go anywhere else. So we have 1, 2, 3, 4, 5. The blue could technically go down here. It's unlikely, but it could. So we don't necessarily have to go that way. This orange needs a 9, and it needs a 3. Well, this can't be 3 or 9, so this cannot be orange. So we know this is a boundary, and therefore it must go here, and this is 3 or 9. This can't be 6 because of the 1, 6 pair in the column. Therefore, we have a 3, 7 pair in row 8, which eliminates 3 and 7 in the rest of the row. Therefore, this is a 6, which means this can't be 6 here. This is 3 or 9. It could be good 3 or 9 here or 3 or 9 here. We're not sure. Or even 3 or 9. Well, no. Yeah, it could be even 3 or 9 here. This 6 means this can't be a 6. So it is a 7. Which means none of these can be 7. This can't be 7. Those can't be 7. This green needs a 7, so it could continue here. If this is... Okay, so can this ever be 2? If this were 2, it would have to be 8 and 6 or 5 and 3, but neither of these can be... This can't be 3 because of that 3. This can't be 6 because of that 6. So this can never be 2, which forces this to be 2. So if this is 5, it's 1, 4, 1, 4. If this is 8, it's 1 and 7. So this can never be 5 here. Either way, one of these has to be a 1. This is 2, which means this cannot be 2 here. 2 cannot be with 6, so it's 1, 2, 7, 8, and 9. We need a 3, an 8, and a 7 for the yellow. This can no longer be 5. This is 3, 7, or 8. This is 3, 7, or 8 here. Because of this 5. Remaining digits in column 9. We have 2, 5, 2, 3, 5, 7, 8. I think this is 2, 5, 7, 8. Ah, this cannot be 3 or 9, so it cannot be orange. So this is dark. Because the orange only needs 3 or 9. This is a separate region, and we know that because both of these have to be 3. 2, 5, 2, 5, 1, 6. These can't be 7 because they're part of the blue region, which already has a 7. This can't be 2 here because of this 2. This can't be 3 because of this 3. So this is 5 or 8. This can't be 9 because of a 9 here. Can this 9 be part of a non-pink region? Well, it can't be part of yellow, can't be part of blue, can't be part of red. So it would have to be its own region, and this is only 7 cells, so this has to be part of pink. So this is part of pink because this blue has to go this way and is blocking this 9 from extending to here. So this is part of pink. We have 1, 2, 3, 4, 5, 6. We need 7, 8 connections. Okay, so this can never be part of yellow. It can't be part of its own region. It can't be part of blue. So this must also be part of pink, which means this can never be 6. We have a 3, 5, 8 triplet now in row 7, which eliminates 3, 5, and 8 from the rest of the row. This must be a 6 and cannot be part of pink. Therefore, this must be part of blue. Cannot be part of yellow because it's this 6. And so it must be part of blue. So this is part of a region here. This must connect to pink here because there's no other way to connect it. This is blue or pink. How many yellows do we have? We have 1, 2, 3, 4, 5, 6. These are the only 7 that could be for yellow. So these are all yellow. This is yellow. So this is all a separate region. We have 1, 2, 3, 4, 5, 6, 7, 8 pinks. 1, 2, 3, 4, 5, 6, 7 blues. So this one has to be blue no matter what. So this is a separate region. This is separate. This is separate. We have a 3, 5, 8 triplet. Actually, we don't know if that's, yeah. That does not have to be part, well, this cell sees both of these, and it also sees that cell, and all 3, 5, and 8s are here, so this cannot be 3, 5, or 8. Therefore, this is 7, which makes that a 3. These can't be 3. We have a 7, 8 pair here. This can no longer be 7. This is 1 and 4 adding up to 5. So this is 5, this is 3, this has to be 8. We have a 7, 8 pair here, which eliminates 7, 8 from the rest of the row. Therefore, this is 3. This cannot be 3. That's 3 in the corner. We celebrate because we know we're getting close to solving this. The rest of row 6 have to be 5, 6, 7, 8. But this cannot be 6 or 7. We have a 5, 8, 5, 8 pair in the blue and in the rest of the row. So this row 6 cannot contain 5 or 8. So this must be 6. This can't be... Whoa, we have a problem. We have a contradiction. No, we have a contradiction. Frig. Oh, wait, this doesn't have to be 7. Why did I have this as a... No. Okay. Yeah, okay. Let's go back to when we had that be a 7, right? I think that's a problem there. I think the rest of this logic makes sense. Okay. This does not have to be... Again, this has to be 3, 6. The low here has to be 1 or 2, but we know this is 4, 2, 1. I think. Let's go through. Let's see if the logic holds, even if we have no a possible 9 somewhere. So we still had this, right? Right. This still had to be the same logic. So again, this had to have 7 to 5, right? Because this digit had to be, we tried to have it as a 2, but if this were 2, this would have to be 4, which would make this 2 4, and therefore that would be a contradiction. So this is 1 or 4. If this was 1 or 4, either way, this is 3 or 4. If this is 1, the 1 has to be here because this could not be 1. If it's 4, 4 has to be here. So either way, this adds up to 7, which makes this a 3-4 pair, which means this is 2 and 5. This can't be 2 because this has to be 2 next to the 1 or 4. So this is 1, 4, 1, 4 next to 2. This 9 still could be here. The 9 cannot be here, though. But we still had the logic, which basically said this is 3 and 6. If we try to have this as a 1, the problem is there's no low possible now here. 3 can't be here because 3 has to be with 8 or 9, and the problem is this is problematic here than here for this 3, 8, 4, 6 pair, a 3, 6, 4, 8 pair. If they have 3, 8, and 8 here, that eliminates 3, 6, and 4, 8, and neither of these cells could work. So 1 has to be one of these two digits as the low. 4 obviously can't be because 4 can only be with 9. 2 can't be because that has to be a 2 here. So this does have to be 1 here. This has to be 4, which forces this to be 4 and 8. This is 3 and 6. So yeah, all the logic is still the same. It's just that I could not have the 7 being there. So let's go up to the point where we had the 7. So this is all still kosher. Okay, so that was this point where this is incorrect. This is 7 or 9 here. This can't be 5. This becomes 3, 7, or 8. This is 3, 7, or 8. Okay, so this logic is still the same. This cannot be part of blue because it already has a 9. Cannot be part of yellow because of the German whisper rule. And if it's a separate region, the problem, not pink, this is not large enough. So this must be pink. So since this is pink, this 6 is similarly, it cannot be part of the pink, sorry, it can't be part of the blue region because it blocks then the pink. Can't be its own separate region because that would also block the pink. So this must be pink, which means this cannot be 6. Therefore, this is 6 and non-pink. Well, the only other region it can be is blue. This then must connect here. This is blue or pink. This yellow can only be this size. So these are not blue, these are both yellow. So this is there, this is here, this has to be yellow also. This cell sees all 3 of these cells, so that's still valid. And it cannot be 3, this then has to be 7. This cannot be 2. This can't be 7 or 5 because it sees all of these regions anyways. This then has to be 5. So this is a 1, 4, 1, 4 pair, which eliminates 1 and 4 from the rest of the rows. So this is 2. This can't be 5. This is 3. This is 8. This cannot be 9. The rest of row 6 is 5, 6, 7, 8, 5, 6, 7, 8, 5, 6, 7, 8. This cannot be 6 or 7 here. This cannot be 5 or 7. It cannot be 8 because of the 5, 8 pair in the row. So this must be a 6, which makes this not a 6. This must be 7. Therefore, this is 9. So this cannot be 9 here. This can't be 6 here. If it's 7, this is 1 or 2. If it's 2, it could be 7, 8, or 9. That's fine. So 9 and 7 are eliminated in column 1. So it has to be 3, 4, 5, 6, 8 for the rest of column 1. This is a 5, 8, 5, 8 pair in the blue, so the rest of the blue cannot contain 5 or 8. This cannot be blue then. This must be pink. So we have the full region of pink. Blue has to go out here twice. And it must be a 1, 2, 3, 4 triplet or quadruplet in that this 7 means this can't be 7, so this is a 3, which means this can't be 3 here. This can't be 1 or 4. This can't be 3 because of that 3, so this is a 2, which means none of these could be 2. This can't be 3 because of that 3. This can't be 3 or 9, but the 3 or 9 could go up here. We have a 1, 3, 4 triplet in row 5, which eliminates 1, 3, 4 in the rest of the row. This can't be 3. This is a 5, 8, 9 triplet here. This 7, 8 eliminates 7 and 8 from the rest of the row, so this can't be 8. This is a 3. None of these then can be 3. We do have a 3 in the corner, and we know we are close to solving it because we just fixed that. This blue region is all done. This cannot be orange because of the orange region needs a 3 or 9. This has to be part of the medium gray because it can't be part of orange because, again, this requires a 3 or 9 for the orange. This could be orange or gray. This could be orange or gray. This cannot be green. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be part of the gray. So 1, 2, 3. This cannot be part of dark, so this has to be the light region. So this is light, this is light. It has to get up somewhere. This is a separate region. This is a separate region. This becomes 5, 7, or 8 here. This is not part of the green region. If it goes this way, this region's too, well, technically it could be part of the light region. The green region needs a 9. One, 2, 3, 4, 5, 6, 7. You can only reach 9 here or 9 here. That's possible. So green does have to go either here or here. Those are the only possibilities. Huh. So none of these can be green. 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this can never be part of the light region. This can never be part of this dark region. Can it be part of this medium region is the question. So it cannot be part of this light region because if this is not green, this has to be the green and this has to be 9, right? Well, either way, this light region is always getting a 9, so that can't be part of that region. It cannot be part of the dark. Can it be part of the medium if that's the case? Well, the problem is the medium cannot go this way because it will block the dark off. So it would have to go essentially this way. And if it did that, the problem is the light is not large enough. So this always has to be green. So this cannot be green here. Therefore, this is a full region. if the dark goes here, so this could be dark, or it could be light, or it could be medium. If it's dark, the problem is that it has to go this way, and this is a separate region, and that's not allowed. So this cannot be dark. Therefore, I think the dark has to continue all the way over here. This cannot be 4 because of the 4 in the region, so this is a 4 here. So we have the full dark region. The rest of this is light or medium gray. This is light or medium gray. Okay. Remaining digits in column 3 are 2, 3, 4, 8, 9. Oh, this can't be 5. So 2, 3, 4, 8, 9, 2, 3, 4, 8, 9, 2, 3, 4, 8, 9. But this can't be 3 or 4. Remaining digits in column 4 are 1, 5, 6, 7, 9. But this can't be 7. This is fine here. Remaining, that's a lot. Remaining digits in column 6 are 1, 3, 4, 7, 9. This can't be 3 or 4. This can't be, wait, no, it's not 7, 9. It's 1, 3, 5, 4, 5, 9. So this is 1, 5, 9, 1, 3, 5, 9. Remaining digits in, okay, this 5 means this can't be 5. Therefore, this is 8, this is 5, which makes this not 5. Remaining digits in column 7 are 1, 2, and 4. This can't be 4 because of this 4 here. Okay, so one of these is a 6, one of these is a 6, so the rest of the rows 3 and 4 cannot contain a 6. Actually, where is the I think we have, yeah, we have 6 here, 6 here. Where is a 6 in the dark region? It has to be here. So this is 6, cannot be here, or row 1, whatever you want to call it. Where is the 5 in row 1? It cannot be here because of the German whispered line. Can't be here because of this 5. Can't be here anymore because this is 6. Can't be here because of the German whispered line. Can't be here because of this 5. Can't be here because of this 5. So it must be here. So this is 5, which means this cannot be 5. We have a 7, 8 pair, which eliminates 7 and 8 from the rest of row 1. So this can't be 8, this can't be 7 or 8. This can't be 7 or 5 because of the 5 or 7 in the column. So this must be 2, which makes this a 7. Therefore, this cannot be 9. We have a 1, 2, 1, 2 pair in row 1, which eliminates 1 and 2 from the rest of the row. This has to be a 5. This can't be 2. This is a 9. These can't be 2. This can't be 9, so this is 8, which makes that a 5, which makes that a 9. These can't be 5 anymore. These can't be 2, 8, or 9. It's a 3, 4 pair here. This is light. 3 and 6 are here. We have a 6 here. That's fine. This cannot be 5 or 9 anymore because of the 5 and 9 in the column. So this is 1. This can't be 1, 5, or 9. This is 7. This cannot be 7. So we have a 5, 8, 5, 8 pair in column 2, which eliminates 5 and 8 from the rest of the column. Therefore, this is 7. This has to be 8. This is 7. This is 8. This 1 eliminates that 1, so this is 6, which makes that a 1. This 6 eliminates that 6, so this is 8, which makes that a 6. This 8 eliminates that 8, so it's 5 and 8. This 5 eliminates that 5, so this is 2 and 5. This can't be 1 anymore. This can't be 1. The remaining digits here in row 4 are 3, 4, and 9. Remaining digits in row 3 are 2, 3, 4, and 9. Okay. These have to be different regions for the 7s. This 8 is not part of this 8, so this has to be essentially the medium region. Okay, if this were the light region, this would cut the medium region off, so this has to be the medium region. Same here. If this is light, it would cut off the medium region, so this is medium. I think same with these two, right? So this cannot be 2, because if it were 2, we know it's part of the medium region. So this has to be 4, which makes this 3, which makes that 4. This can't be 3 or 4. This is 9. This can't be 3, 4, or 9, so this is 2. That makes this a 1, which makes that a 2. This 4 makes this a 1, so this cannot be 1 here. This can't be 9, so this is a 3. That leaves this as a 9. So we have 1, 2, 3, 4, 5, 6, 7, 8 already in the medium region. It needs a 9, so it has to be here. So this is the medium region, which means we have the full medium dark region, so it has to be here. This has to be orange then. And these cannot be medium. So these are the lights. This 3 means this can't be 3, so this is 4, and this is 3. This 4 eliminates that 4, so this is 1, and that's a 4. Whew! Whoa! You snap out of your meditation with sudden clarity. You realize you've been seeing those zip lines embedded in the walls of the castle. Now understanding how they work, you may be able to find another way to the throne room. The guru calls out as you turn towards a large zip line in this place. Take heed! The Hall of Illusions is not to be taken lightly. Many of the clues there cannot be trusted. You feel a knot in your stomach at the thought you may have been misled, but steel yourself for the task ahead. Your increased clarity allows you to ride zip lines throughout the castle. Enter 4 in this puzzle's boss digit. So we have a 4. We're going back now. So we have a 4 in the boss area. And yeah, those red lines were all zip lines, which I'm not good at, so that might take a while. We have a 4 in the boss region. Where are we here? So we know this is a 4. Okay, we have a zip line. Wow, that's really long. Okay. This is the center point, though. So these two add up to 8. So it must be 8. So this is 8, which makes this a 5 to add up with 3 and 5. These two must add up to 8. So this must be a 1-8 pair here. Because the only digits in this region, which are not in this row, are 1 and 8. So this is a 1-8 pair here. This is 8. These two add up to 8. So this is 3. This is 6. This is 5 added up with 8. Or sorry, add up with 3 to add up to 8. These can no longer be 5 or 8 here. This can't be 5 or 8. This can't be 5 then. This is 4 or 7. So it must match here. Because this red, again, this red has to be here because there's no other place for this region. In row 8, the red cannot be here. The red cannot be here is one of these 4. Therefore, this cannot be red. This cannot be red. This cannot be red. And this can't be red. So this has to be the red, which means this is the red. This can't be 5 or 8 here. This is an 8 and 9 pair here. 5 has to be one of these 2 digits because 5 cannot be here anymore. 5 can't be here. So this sees 5 in going in this direction. So this cannot be 9. This sees 3 going in this direction. Therefore, where can the 9 be? 9 cannot be here or here. 9 can be in one of these 2 spots. Because it must see at least 3 digits this way. It must see at least 5 digits this way. Okay, these digits, so we have 3 and 5. The other ones are 1, 6, and 2, 7 to add up to 8 because they see each other, so therefore they must be unique. So this is 1, 2, 6, 7, 1, 2, 6, 7, 1, 2, 6, 7, and 1, 2, 6, 7 here. These also see each other. Cannot be 6. Cannot be... Well, okay, hold up. So it's 1, 3, 5, or 7 here. This is 1, 3, 5, or 7. But this can't be 3, therefore this can't be 5 here. This can't be 6, therefore this can't be 2 here. This can't be 6, so this can't be 2. So 6 in this region has to be one of these 2 digits. 2 in this region has to be one of these 2 digits, then, to add up with the 6 to add up to 8, because 6 cannot be here or here. Therefore, 6 has to be one of these 2 cells. The remaining digits are 8, 4, and 9. 4, 8, 9, 4, 8, 9, 4, 8, 9. This can't be 4, 8, so this must be 9, which means this cannot be 9, and this cannot be 9. This is 4, 8 here. This is 4, 8 here. 2 has to be one of these 2 digits, which means this cannot be 2, so this is 1, which makes this a 2. This is 1, so neither of these can be 1. We now have a 2, 7 pair in column 8 and in this region. So this cannot be 7, this cannot be 7. This can't be 7 then. The rest of this region is 3, 4, 5, 8, 9. Which doesn't tell us too much. The rest of this region is 2, 4, 5, 7, 8, 9. That's not telling us much either. Neither of these can be 9. 9 could be any of these 4. This can't be 8 anymore. This can't be 3 or 8. Where is the 2 in column 9? Can't be here. It has to be in this region here. And it can't be here because of this 2. Can't be here because this is the red. Can't be here, can't be here. This must be a 2, which makes this a 7, which makes that a 2. This 7 adds up with a 1 to add up to 8, and this must be 6, adding up with 2. Okay, so this is not the red. So one of these 2 is the red. Okay. Any of these could still be the pink. We're not sure which. The rest, okay, this cannot be 9. So since this can't be 9, where is the 9 in column 3? It has to be here. So this is 9. It sees 3 this way. None of these can be 9 then. One of these 2 is a 9. One of these 3 is a 9 here. Okay, remaining digits in row 5 are 2, 3, 5, 6, 7. This can't be 6. This can't be 3 here. We have a 1, 8, 1, 8 pair, which eliminates 1 and 8 from the rest of column 5. So this is 7, which makes this a 4. This is then the pink matches here, which makes this a 7, which makes this a 4. So this is also a 4, which means none of these can be 4. This cannot be 4, this cannot be 4. So 4 has to be one of these 2. This can't be 4, obviously. This 1 means this can't be 1, so this is 8, which makes that a 1. This can't be 7. This 4 means this can't be 4, so this is 8, which makes that a 4. This then can't be 4, this can't be 7 either. So this can't be 4 or 7. This can't be 4 or 7. This 7 means this can't be 1 to add up to 8. We have a 7, 9 pair here, which eliminates 7 and 9 from the rest of the row. So this is a 4, 8 pair here, which means this can't be 4, 8. It's a 5, 7 pair here. 4 is one of these 2. This is 7. The remaining column... Okay, so this sees... Oh, wait, no, this is just a 2. It's not a scribe peeper. Okay. The remaining digits in column 5 are 2, 5, and 9. This is 2, 5, and 9. This is 8 or 9, so this must be low, and it cannot be 5, 7, or 8, so this must be a 2. Which means this can't be 2, this can't be 2, this can't be, these can't be 2 anymore, so 2 has to be one of these 3. 4 has to be one of these 2. This must see 3 digits this way. And it must see 5 digits this way. So this could be up to 5. So this is 1, 2, 5. This could be up to 6. This cannot be 8. So 8 cannot be any of these digits here. Therefore, 8 has to be one of these 2. So one of those 2 is an 8. This is 1, 2, 5. This is 1 through 6, but can't be... Okay, can't be 6. This is 1, 2, 4, 5. If this is 7, it would only see 4 digits. So this can't be 7. This has to be 5, which makes this a 7. Neither of these are 5. So this can't be 5. This can't be 5. 4 cannot be here. So this is a 1, 2 pair here, which eliminates 1 and 2 from the rest of the column. Therefore, this is 3. This can't be 2 or 3. This is 6 or 7. This 3 means this can't be 3, so this is 1. This is 7 to add up to 8. This can no longer be 7. 7, there's no 7 here, so this is 9, which makes that a 7. This can't be 7. These can't be 9 anymore. And this can't be 6 because of this 6. So we have a 7 here. One of these 2 must be a 7 because this can't be 7 and this can't be 7. So this is not 7 here. Okay, so we can remove the coloring. We just have the digits now. This can't be 8 because of the 8 in the row. The remaining digits in row 6 are 3, 5, 6, 7. So 3 and 6 are both here. This cannot be 5. This can't be 3. We have a 6, 7, 6, 7 pair here. That eliminates 6 and 7 from being here. This becomes a 4, 8 pair. But if this were 4, this would be 8, and therefore it would see 4 cells. So this cannot be 4. This must be 8, which makes this a 4, which makes that an 8. This 8 means this can't be 8, so this is a 5, which makes that an 8. This 8 eliminates that 8, so this is a 9, this is an 8. None of these can be 8. These can't be 9 anymore. This can't be 7 because of this 7. The remaining digits in this region are... This has to be a 1, 6 pair here. So this is a 1, 6 pair. We can eliminate 5 and 8. This can't be 5, so this is 9, which means this can't be 9. We have a 3, 4, 9 triplet in this region, which eliminates 3 and 4 in the rest of the region, and 9. This is a 5, 8 pair. This has to be 3 and 4, but this can't be 4 here, so this must be 3, which makes that a 4. Therefore, this can't be 3 here. Whereas the 3 in row 6, it has to be here, so this is 3. This can't be 2 or 3. The rest of this region here is 1, 2, 5, 6, 7. And it could be any of those. The rest of this region is 2, 5, 8, 9. 8 cannot be here. 8 cannot be here. Where is the 8? It has to be here. So this is 2, 5, and 9. This is 2, 5, or 9. This can't be 7 because of that 7. We have 1, 2, 5, 6, 9 in column 2. Okay. This cannot be 2 here because of this 2. We have 1, 5, 6, 7 in column. Okay, this can't be 7 because of the 7. This is 1, 2, 5, 6, and 9 in the rest of row 9. But this can't be 1. We have a 3, 4, 5 triplet in column 7, which eliminates 3, 4, 5 in the rest of the column. Therefore, this can't be 5. This is 8, which makes this a 5. This can't be 5, which makes that a 7, which makes that 6. This is 5. This 6 eliminates that 6, so this is 7. This can't be 7 here. This 5 eliminates 5 here and 5 here. This sees 5, 6, 7, and 9, so it cannot see 1 and 2 because it sees 5 digits, so this must be 2, which makes this a 1. This can't be 1, this can't be 1. We have an exclamation point, so we've unlocked zip lines here. Oh, we already did unlock zip lines, I thought. Anyways. This can't be 5 or 6 here. This is a 7, which makes this a 2. This can't be 2, so this is 9, which means these can't be 9. This can't be 2 or 9 here. This can't be 2, this can't be 2. There's no 7 here. This can't be 5. This can't be 9 here because of that 9. So this is 5, which makes that 4, which makes that 9. This 4 eliminates that 4, so this is 3 and 4. This 3 eliminates that 3, so it's 5. This 5 eliminates 5's here, so this must be 6. This is 2, this is 3. This can't be 5 or 9, so this is 6, which makes this a 1, which makes this a 6, which makes that a 1. This 2 eliminates that 2, so this is 5 and 2. This 5 eliminates that 5, so this is a 9. This can't be 1 or 6, so this is a 5. And we should have finished that one. Yep. That's solved there. Unlock zipline fast travel. I actually didn't check to make sure that we actually had all this. We had the zipline rule set there. Okay, we did have the zipline rule set. Let me just, okay, first of all, let me go through here, and then let me reload. I don't want to lose all my progress, potentially. Cells equal distant. Okay, so that's zipline. Let me just check for the 1. Yeah, so we had the rule already. Okay, we have a long zip line. We want to try to solve that. What is this? Okay. Outside cells on thermos or arrows can be blank. But whip arrows must still sum to a digit in the whip circle. Okay. What does that mean? I don't really know. Okay, this sees only 2 digits, so this must be a 2 here. Okay. For scribe peepers. There, and it matches here, so this, well, we are not guaranteed that, so maybe we shouldn't do that one yet. Okay. Okay, this enters here and exits out here. I don't, okay, so this is a thermometer. This is a thermometer. Again, they said outside cells. Outside cells on thermometers or arrows can be blank. But whip arrows must still sum to the digit in the whip circle. And this then must be a 9. So these cannot be greater than 8. So this has to be a 1. Okay. Outside the boxes. Solve clues outside the grid. Solve the outside tutorials. Okay. This has to be blank because it's next to a 1 and a 9 on a German whisper line, and that's not allowed. This is a 2. This also must be 3. So this is 3, which makes this a 3. It is 3. That's 4, 7, 9. Oh my god. You found a hidden puzzle. More. Okay. I need to see the outside rules. I'm not sure how these work. Okay, black dots always border 2 digits. Black cells on whisper lines. Blank cells on whisper lines are ignored. Okay, so we sort of assumed that anyways. This has to be blank. So this is, we're going to make this specifically dark. So this is blank. These are all blank. So we're going to make those dark. This has to be blank. Black dots always border 2 digits, so this must be a 0 then. And this must be a 4? So this has to be 9 here. This has to be... Zero is in a 1 to 2 ratio with 0. Oh, but okay. Okay, yeah. This doesn't have to be filled. Right. Zipline centers must contain a digit. Pair some to the center even if one is blank. Oh. Interesting. Okay. Huh. Okay, so that's actually kind of weird because we already assumed that this was 5. Huh. Oh, but it's still... but you didn't have that knowledge here anyways. That is weird anyways. Okay. Anyways. Okay, let's reset. Do we want to continue this right now? I feel like if I don't continue this, it will be longer for the rest of the solve. So then this must be 9 and 9. Okay, that gives us more information here. Okay. We found a hidden puzzle. Okay, this is getting far off. The learned rules have not changed. We have solved the outside tutorials. We need to solve the fast travel zipline. Okay, so this is... Okay, so black dots are always in between 2 digits. So this is 6, which makes this a 2. German whisper lines can be blocked. Two can be in a 1 to 2 ratio only with 1 or 4. Okay. So this is 1 or 4. If this were 1, this would have to be 7, but 7's not in a 1 to 2 ratio with any digit. So this has to be 4 and 4. So this is 4, this is 4. This is 2 or 8, which means this is 0 or 6. If it's 8, this could be 4 or 1. Okay, so if this is 6, this would have to be 1, but 1 doesn't add up with anything, so this cannot be 6. This has to be 8. This is blank, so this is 4 and 4. Okay. So again, black dots always border 2 digits. Blank cells on whisper lines are ignored. So therefore, that's 8 and 0 works because 8 and 0 have a difference of 5 between them. Outside cells on thermos can be blank. Whip arrow still must sum to the digits. Okay, so we don't have... Okay. So this is 3 and 3. These two are the same. These two are the same. These two are the same. Hidden puzzle designated by serpent. Enter digits from 1 through 4 into each of the row columns in 2x2 boxes. So these digits are 1 through 4. Oops. Okay. That means these scribe peepers are at most 4 also. Okay, so this 2 matches with that 2. This 3 matches with that 3. These are going to be the same. We'll make these pink. We'll just make these in some sort of random coloring. Yellow, and these are both blue. Okay, so these two are the same. So if this were 4, it would see 4 here and would only see 1 skyscraper, so that doesn't work. If it's 3 here and 3 here, it would see 3 sky peepers, but this could only see 2 at most, so that can't be 3. If it's 1 and 1, this would see at least 2 sky peepers, so this would not work. So this has to be 2 and 2. So this is 2, this is 2. These cannot be 2 anymore, so this can't be 2 here. This can't be 2 here. If this sees 1, it could see 4 here, so that's fine. If this is 4, it cannot see 4 here. So this is not 2. This is not 2. This is not 2. If this sees, again, if this is 1, it could see 1. If this is 3, this could still see 3. It cannot be 4, though, right? If this is 4, it would not be able to see 4 skyscrapers here. If this is 1, this would be 1, and it would... Wait. No, this could be 4. It's the yellow, which cannot be 4. So if this is 1, this would see 4. If this is 3, this would be 3, and it would have to be 1, 3. So this is either 1 or 4 here. If this green is 4, it could not be, because this is either 1 or 4. So this can never be 4. Can this see 3? If this is 3, okay, if this is 1, these are both 4, and this is 1. If this sees 3, I think the 4 would have to be here, right? This sees 2, so this can never be 3 here. Where is the 3 in this 2x2 box in the lower left? It has to be here. So this is 3, which makes this 3. It sees 3. So this is 1, this is 4. This has to be a 2-4 pair. This is 2 and 4, but this can't be 4, so this, because of this 4 here. So this is 2, this is 1, which makes this 2, this is 4, so these can't be 4 here. This 4 means this has to be a 1. So this sees 2 digits, this sees 2 digits. This can't be 1, this can't be 4, it's 3. This is a 3, this is a 1, this is a 2. This has to be 4, this is 3, and this is 4. Serpent. I don't know what serpent is. Okay. So this 2 sees 2 skyscrapers, 3 and 4. This sees 3 and 4. This sees 3, 1, 3, and 4. This sees 2, 2, and 4. And the 2's match, the 3's match, the 1's match, the 2's match, the 3's match, and the 2's match. Okay. We didn't get a check mark for that, but okay. So this is not this is not a digit. So blank cells on whisper lines are just ignored. Okay. Let's see. What else do we have here? You could have blinks on thermometers. Okay, these have to be digits. And they're in a 1 to 2 ratio. And this has to be increasing from this way. So it cannot be 4 and 8. It could be 3 and 6 here. 2 and 4. Or 1 and 2. So this has to be 5, 6, or 7 here. With 2, 4, or 6 here. We're not sure. So this has to be a 6. And this has to be a 2. Which, oh god. And this is a 2. To add up to, with that. This is 0, so this must be an 8. This has to be a 5 to add up with 3. We have 1 and 7. This is 4 and 4. This is 1 with the 7 here. This is 4 with the 4 here. This is 7 with the 1 here, and this must be a 6. Heed the guru's warning. All clues contained in the Hall of Illusion grids are lying. Oh boy. Okay. I think I've started filling in one. So all the ones are lying in the Hall of Illusions. Okay, we're not going to target that. We're going to delete some stuff then. Okay, Hall of Illusions as portrayed by wronging clues. Clues contained entirely inside. Okay, clues contained entirely inside the Hall of Illusions grid are wrong and indicate the opposite of their normal rules. Digits in wrong thermometers increase as they get closer to the bulb. Digits in wrong whisper lines must differ from adjacent digits in... Okay, so that's why this didn't work. Okay. So we will just delete all of this then. So these are not correct, period. Because these are wrong clues. Digits in wrong thermometers increase as they get closer to the bulb. Digits on wrong whisper lines must differ from adjacent cell digits by less than 5. Okay, we're gonna have to figure this out later. Okay, this is wrong then also. Because it's entirely inside the Hall of Illusions. I found another hidden puzzle. Designated by Wolf. In this 4x4 grid, enter digits 1 through 4 into each row, column, and 2x2 box. Okay. So these two match. These two match. These two match. So we have green, red. Okay, so this is red and red. This is yellow and yellow. This is blue and blue here. We have light and light. Medium and medium. And dark and dark. So these are 1, 3, and 4. This could be 5 through 8. I don't know. These are all 1, 2, 3, 4. This can't be 2. This can't be 2. These can't be 2. Okay, these match. This green and that green add up to this digit. This pink and this pink add up to that digit. Orange and orange. Red and red. Yellow and yellow. Blue and blue. Okay, so pink and pink, yellow and yellow. These grays see each other. So this is at least 3. So it could be 3, 4, 5, 6, or 7 potentially here. Right? If this is 2 and 1, this could be 2 and 1, and this would be 2 and 1. So if this is 3, this has to be 2, this is 1. No, it must contain a 4, at least. Okay, so it must yeah, because all of these must contribute to something here. So this has to be at least 4. Cannot be 3. Can it be 0 and 4 is the question. This is with something inside the grid. This is with something inside the grid. This is with something inside the grid. This is not, though. These two add up together. The green is with something inside the grid. The light is not. The red is something outside. Yellow is not. So we've done all 4 of these. Blue, yellow, and red and orange. Orange could be outside the grid. So it still could be 4. Can it be 7? If you have 7, that forces this to be 3 and 4. I don't think that works, right? If you have 7, that requires 1 and 2 to have stuff outside the grid, and there's only 1 at most, right? This red is the only one outside the grid. The yellow is not, the blue is not, and the gray is not. The medium gray is not. So this cannot be 7. You could have 6 potentially. That means the 1 has to be with stuff outside the grid. The 2 could be with 4. The 3 could be with itself. And the 1 would have to be outside. So if that's the case, okay, so if this is 6, this would be 2 and 4 to add up to 6. This is 2 and 4. This would have to be 3 and 3. This would be 1. This is 2. This is 1 and 4. So this would be 2, and this would be 4. This would be 1, 5. This would be 1, 5. And this would be 3 and 3. So that could work, and this would be 1, 5. So that could work. And this would be 5, and this would be 5. Okay. If this is 4, now that's interesting. Then this would be 3 and 1. This would be 1 and 3. This would have to be 4. This would be 2 and 2. This can't be 2 and 2. Okay, so that does not work. 4 does not work. What about 5? 6 seems to work fine. That's interesting. If this is 5... Okay. This is pretty complex. These two add up to 5. So these two, that doesn't work. So if this is 5, these two add up to 5, and therefore these two would add up to 5. But we know these two must add up to 5, and therefore it's a contradiction. Therefore, this must be 6. This has to be 2 and 4. So this is 2, this is 4. This is 2 and 4. So this is 2, this is 4. This is 3 and 3. This must be 1 with 5. The greens again must be 2 and 3. This must be 2 and 4. So this is 4, this is 2. This is 1 with 5. This must be 3 and 3 adding up to 6. This is 1 with 5. And this is 1 with 5. And this is 4. So that should solve something else. Yep, we solved wolf. Oh, serpent, I guess, is this one? Yes, this is serpent. That's a hidden puzzle. I don't know what hidden puzzle I solved here, but I solved a hidden puzzle. Okay, we have not solved the outside the boxes quest given by the Sudoku Guru. You have learned much, but you are still bound by the confines of the grid. Only by letting your mind go free can you truly understand the essence of Sudoku. Remember, all clues outside of the examples in the Learned Rules panel must be correct. Solve the clues outside the castle's grid to complete the quest. Cells outside of the grids may contain a 0, or they may be blank. Examine the clue rules closely to deduce which cell must be filled. Okay. None of these have to be filled. right? Even the palindrome doesn't have to be filled, I don't believe. This doesn't have to be filled. This doesn't have to be filled. But it's still not, yeah, because we don't know what these are. Right, we know we're guaranteed that these are definitely part of the puzzle. But we don't know which. We've solved all of this. So it's just this part then here. So if this is 6, this is 3. This has to be 2 and 5 then. That seems fine. If this is 2 and this is 4, this is 4 and this is 6. That's fine. If this is 1 and 2, this is 6 and 7, and that's fine. So I don't know how we solve that then for the rest of it. Do I want to spend some more brain power on that? I don't know. Outside cells on thermos or arrows can be blank, but whip arrows must still sum. Right, we have whips. Zipline centers must contain a digits. Pair sum to the counter center even if one is blank. Right. So we don't have any other information here. 17 has to be between 2 digits. Do we even care about that? I don't even know. Find Mr. Steak's hidden food. Okay, I don't know if that... Done that, we've done that, so that's all kosher. We don't know... I don't think we have enough information here, right? We filled out all of this, so this is fine. We filled out all of this, so that's fine. We don't know if we have something here. Yeah, because the thing is, none of these zip lines necessarily have to have a digit, right? Actually, doesn't this have to have a digit? Maybe. But this could be blank or 0. And this doesn't have to be greater than this digit, right? Because it's not on the thermo. That's weird. Does every line on the zip line have to contain... I think yes, every pair of zip line digits must add up to 8, no matter what, right? Yes, pairs sum to the center even if one is blank. So therefore, these all have to have at least 1, essentially. Okay, so that's what that means then. So we do have to fill in that entire zip line. Interesting. So at least one of these must be filled, right? If this were 8 and this were blank, that would not work. Because this has to be less than this, and it has to be greater than this. So, right. This is at least 5. Okay, so this is 3 or less. That means we need 2 blanks at least, right? This is 3 or less. You could have 2 and 1 somewhere here, and we need at least a blank or a 0. I think it has to be then 3, right? It can't be blank, 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 right? So one of them's blank, one of them's 0, or they're both blank, right? What we do know then is we have 2 and 1. So say this was 8, right? This would also have to be 8. But then we would need 8, 8, 8, and then this would have to be, I guess it could be blank, blank, blank. That could be the case. It has to be continuously increasing. The thermometers, again, does not have to have a digit on it, right? Is that the way that's said? Yeah, I think so, right? Outside cells on thermometers or arrows can be blank, but whip arrows must still sum to the digit in the whip, right? So I didn't see another whip arrow. Blank cells on whisper lines are ignored. That's fine. Zipline centers must contain a digit. Pairs sum to the center even if one is blank. Okay, so this could be essentially... Okay, you cannot have 8 and 8 here. Okay, so... None of these can ever be 8. Because if there are 8, we know these are smaller. These have to be bigger than it, and none of them can be 8. So because none of these are 8, all of these are filled. So this has to be greater than this. This is 6 at least. This has to be greater than this. This is 6. This is at least 7. This has at least 8. So this has to be then. We know exactly what this is. This is 8. This is 7. And this is 6. This then has to be 8. This is 1 and 2. These are blank or 0, depending on how you want to, whatever. This is 3, which makes this 5. This has to be 6 to be in a 1 to 2 ratio. This is 2. And this can never be 8, so this is 7, and this is 1. Did that solve it? I don't think it did. So that means we need zeros here. I think. I think that this is guaranteed. This is specific, though. Right? So this is a 2. We have not solved the fast travel zipline. I don't know which one has to be 0. Okay, this one had to be 0. I don't know why this one had to be 0, but it did. Solve the title. I don't know what the title is. Okay, so this 0 doesn't have to be here. I don't know why this is not... Why this has to be 0, but this one does not have to be. It seems kind of weird to me. Does the bulb require specifically that? I don't know. No, it didn't say anything about bulbs. Yeah, I don't know why this one has to be blank, but the other one has to be 0. It could actually be the other way around, I think. But anyways. Okay, so we've solved essentially all of the zipline outside. I don't know what solve the title means. We have some other stuff going on. We have wrong clues, but we don't really want to get started in that because that's going to be either... So that's either going to be the start of the last video, or we're going to have 2 videos to try to solve the Hall of Illusion and then the Golden Temple. So look forward to that in the next installment of Sudokuvania, Digits of Despair. I'll see you next time. Take care.